Hello viewers, welcome to Spatial Site. In this video, I'm going to show you how geoprocessing tools are used in QGIS and what is geoprocessing tool all about. Geoprocessing tool in GIS is the commonly used tools that you see like clip, buffer, union, intersection, merge, etc. So in this video, I'm going to show you how all these tools can be used in GIS. So first, let's start with clip. So for to do clip, I'm going to first load my desired data sets. I'm simply going to go here and this data. I got two data. One is this raster dev data and another one is this save file. Okay. This is a raster data that you can see here and my study area is represented by this pink color. To do analysis in study in this only this study area, I need this DAM data of only this study area. So for that purpose, I need to do clip. So for doing clip, you simply go here vector. One thing I want to mention here is that clip does not only mean that clipping a vector data with a vector. It also means clipping a raster data with a vector. Exactly in GIS, it's called raster by max extraction, but it is also a kind of clip. So for this, we need to go to here. Let's go here, raster, extraction, and clip raster by max layer. We are going to here. Now input layer, what we are going to input here is this name data because it is the layer that which portion we want to clip. Okay, and max layer is this CRE word. With this layer we are overlaying this raster and we want to max with this layer. And now, and the most important thing here that you need to take care is that make sure this both two data sets are in same coordinate system. In my case, both are in same coordinate system. You can see it through EPSC 32644 in both cases. Okay, now target CRS, you can simply press this drop down and click this. I have done it previously so that I have seen this option, but in case you don't have, you simply go here and you search other things that you want. And once after this thing is done here, one thing you need to make sure is here the one thing is ticked here, match the extent of clipped raster to the extent of max layer. Okay, both extent of this means this both extent of this this max layer and this output that will come will be the same. Okay, rest of the thing we are going to keep by default. We are not going to do anything here because now another thing is for clipped. Now we need to save it. Now simply press this three dot icons, then save to file. And now you are going to save it here. Now let's go to this clip output, say clip. By default you are seeing this T file. If you press this this bottom arrow icon, you can see all the file format. I'm keeping this is by default. Click on save and finally click on run. Enough, close. Now you can see here. Okay, now I got the raster data of my desired area of interest. So that's how clipping is done in QGIS, and particularly it's called clip raster by max layer. And remember, if you go here and you have seen other option as well, clip raster by extent. If you will do this, enable this option, then you will get the raster of this boundary, but this along with this a kind of rectangular extent also you are going to get. So better to keep this like this. Okay, this was for clip. Now we are going to see other functionalities. Now I'm simply going to remove this layer. Now I'm going to show you how dissolve can be done in GIS. So simply first load those, first let us load that data. Okay, I'm simply click here and drag it to these layers. Okay, this is the data that I want to dissolve. Actually, this data consists of this wards of different municipality, and this makes a one constituency, election constituency area of a district, one constituency area among several. So what I want to do here is I want to dissolve all this boundary. I want to dissolve these boundaries. Okay, once these boundaries are melt and it becomes a combined data set. Okay, so that is what dissolve all about, this removing the boundary. Simply you can say melting this boundary and combining and making this a one. You can see here, let's notice one thing. Let's open this its attribute table, and you can see here, look at here, there are this 23 kind of data sets are here in this yellow region. And once we do this dissolve, this all layers, this 23 data sets are going to be melted, and you will probably see only one data here. Okay, I'll show this how you can do here. So now simply go here, go to vector, and click on this geoprocessing tools, and simply click on this dissolve. Okay, once you do that, and input layer, you need to select this one, which is the layer name. It is the layer that I want to dissolve, and simply, else don't do anything, everything is fine here. Simply just click these three dot icons and save to file. Okay, now dissolve. Simply go to output, and let's say its name, and save as type. If you click on this icon, this sky blue highlighted region, and you can do save it in different format you want, but here for this case I'm simply saving it as SSP. Okay, click on save, and finally click run. Now you can see here. Now simply click right click here, go to open attribute table, and now you can see here, last time you saw here 23 kind of this data sets, 23 features you had seen last time, but now only one feature is here. And why only one feature is here? Because we have dissolved it, so you are seeing only one kind of feature here. So this is what dissolve all about. So we are done with dissolve. Now I will be showing you how the merge tool works. So for that, first I'm going to load all those data that I will be demonstrating here. So simply click here and drag, and do the same for all this. This is for dissolve underscore one, and do the same for 2, 3, 4, and 5. Yeah, we loaded all the data. Now you can see here, Actually, these five different features that you are seeing here are the election constituency of this Rupendehi district. I want to do the analysis of election results in this Rupendehi district in these regions, five this five regions. So what I'm going to do is I don't want this individual layers. I want a merged layer because this individual layers makes the things quite. It's better to hack. It's better to carry a single data layer than instead of carrying this all these five data layers. So what this merge tool simply does is that it it actually merges, or you can say it combines all all features, and it does not matter these features are these features overlay each other or not. It's simply what are the layers that you want to combine. It simply combines, and at the end you will see that the attribute table in the attribute table all the data have come in a merged form. You can see here for this Rupandehi one here, if you right click here, go to open attribute table, and you are seeing like this. Okay, this is chapter number 1 in district Rupandehi and so on. And likewise you are also going to see the same for this other district. Now when you will merge these layers, you are going to see a combined form of all this data that you have seen here. Now, so without delay, and now I'm going to show where you can do merge, how you can do merge. Simply go to this vector, click here, then data management tools, and you can see here merge vector layers. Now simply click here. In this parameters menu, in input layers, now click these three dot icons. Now these are all the layers that I want to merge. Again, the main thing to remember here is this EPSC. They all should be in same coordinate system. You should make sure of this thing. So here all these layers are in same coordinate system, and I'm simply going to select all. Now click on OK. This is done, and destination CRS means coordinate reference system. It's saying I'm simply going to go for 44 north, but it's optional. By default it will come in the same format that you have given in input. Now once the merging will be done, then to save the output we are going to click here, then save to file, and here I'm going to save. Okay, in this save tile you will see different format here. Okay, I'm going with this SSP. Simply save, and finally click this run, close, and now you will see close all these layers. Just now you can see here merge Rupandehi. This is only one feature. If we will merge all these layers and bring in this kind of form, then it will be easy for us to do the analysis to carry the data as well. And now you can see here, just right click here, go to open attribute table, and now you can see here, previously I have shown you that they all contain this only one row, they had that only that one information. But if you see here, now there are five kind of information. Now if you select this, now this will be selected, this one reason will be selected. Okay, later you can separate it at any time. Now this is the thing that you merge tool, and if you don't like, if you're doing the analysis and you don't want this path and this layer because they are not needed, what you need is only this set normal, and you can simply edit this click on this toggle editing mode, and here is one option to delete field, this one, click here delete field. Suppose I don't want this path, I am pressing Ctrl here and layer, then simply okay, then they are gone. And last you can save this and simply click this toggle editing mode. Okay, now you are done here. you can do the rest of the analysis what you want. So this was for how merge, merging is done in this QGIS. Now I'm going to show how intersection works in QGIS. So for this, I'm simply going to select this all. I'm going to remove this. Now I'm going to load those intersection data. Here I got two data. One is this building data, other is road buffer. Simply going to click here and drag them here. Click and drag it here. Okay, now you are seeing here. Okay, simply zoom to layer. Now look at here. Now I'm going to show you the intersection layer, the intersection geoprocessing tool, how this intersection geoprocessing tool actually works. You can see here this all data, this rectangle form are of building shown by this kind of this green color, and this like yellow color is a raw data. Now what analysis that I want here is I want to see, suppose this is a road expansion project, and when the road was expanded, now you will see the houses that will be affected by this project. You can clearly see here, but it's not quite clear that we want it. Now what I want is I just want those houses that will be affected by this project. You can see this here, there are lots of houses here, and but the houses that will be affected by this project are only very few houses. And to show us there what you are going to do now, you are simply going to go with over you are simply going to go with intersection tool. What this intersection tool will do you is, when there are two layers and that overlay each other, intersection simply intersects that common region, and it will show you to it will show you, and from that we can get the number of houses which were affected by this project. And what it does is it actually joins that attribute table. Now you are going to see the houses and the attribute table of this road and these buildings, they are going to be combined. Like you can see here, if you click here, right click here, say it's open attribute table. Now you simply can see here it's OSM ID. I took it from OSM. So this is for buildings. We are seeing here OSM ID, and this name in type is not given here. As if you see in standard data, you are going to see here owner's name and other thing. So I don't need this name and type here so I'm simply going to remove this data. Okay, now you are simply saying this OSM ID here, okay, for this data. And for this road buffer, you are simply saying this OSM ID, this was created by one user, and this road name. Okay, other things fine. Now I'm going to show you how intersection can be done. So for this, simply where you go is go to vector, Geoprocessing tools, and click on this intersection. In this input layer, what we need to input is the data that you want to do analysis. Here my purpose is I want to see those houses that will be affected by this project. So houses is my purpose, is my target. So I'm going to simply click here for this buildings. So I'm going to select this, and overlay layer is I will be keeping here for this road buffer. because now these buildings are being overlaid by road. Overlay means that person is within that road buffer. So I'm doing keeping this overlay layer as road buffer. Now other options you can keep by default, and at last you need to save it. Now what you do is intersections, you go to output and simply say here okay. Now once you are done, save the SSP. Okay, save it, simply click run. Now you will see something here. Now let's close all these things. So now you can see these are the houses that were overlaid by the road, and that are that intersect region. Like we see in that set, if A intersect P, in that middle portion, that is the intersection. Likewise here also the two data layers, buildings and road, that the common region between them are seen here. And so these were the houses that actually were affected, and this portion of houses were being affected by this road project. And what you can see here is, if you right click here, it's open attribute table. Now you actually can see here, yeah, you can see these houses, these all that. If you click here and click here, now you will see some kind of feature been selected by yellow color. So you can keep this background to see where the things are. So these are the houses that actually are being affected by this road. And so this was our intersection. Now see, you can see 14 houses were actually affected. And you can also notice that these attributes were combined. The attributes, this is the attribute of building actually, and this is the attribute of road. And now you can see here, now this the main the feature the main characteristics of this intersection is that this attributes gets combined. So this was for intersection. Now so we are done with the intersection tool. Now we are going to see the how the union tool works in GIS. This union tool, what does this union tool does is that it simply combines the two different layers into one form, like what that previously that merge does. But here what happens is that this merge, it joins them to this new table. And here the two things happen. One thing is that in union, the overlapping portion, the intersected region, that also comes as features, and whereas those non-overlapping portions also come in that new layer. Suppose here you are seeing all these. I have on this two layer, buildings and road buffer. You are seeing here this road data. Here you are seeing this road buffer and this building regions. When we will do the union of these two features, these two layers, you are going to see all these buildings layers, all these buildings, all this road, as well as you are going to see the intersecting portion as a feature. This portion that you are seeing here, this is the intersected one. This is also you are going to see as another feature, along with this remaining portion from here to here. This is also going to be seen, whereas this non-overlapping portion, this will also be seen in if you do this union tool. So to do this union tool, so what is the advantage of this union tool is that, like we saw previously in intersection, you only saw this overlapping portion, this portion, and you could not see the rest of the part of the building as well as the road. But this union tool combines all of them, and you can see the desired, this intersected region here as well, this road, and the rest of this building part as well. So to do this union, I'm simply going to go on vector geoprocessing tools, and I will be going here for union. Here are different kind of, all the geoprocessing tools are done from here, most of them. And you can see here this figure, this icon. This icon speaks a lot about what does this tool does. So I'm simply going to go click on this union, left click it. Now in this input layer, I'm going to select this buildings 44 north, and overlay layer is I want to overlay road buffer. So as I told previously, make sure both your data sets are in same coordinate system. Now what I want to do here is that I'm giving the input layer as building. That means I want to see the all the buildings portion, and along with these buildings, you are going to see the road data as well, because it combines, it simply joins that attribute of another layer as well. This layer or attribute also you are going to see in the same row feature of building. So now, okay, two things are done. Then you simply click these three dot icons, save to file, and in this union output, I'm simply going to say it building union. Save type is SSP. Okay, save. Click on run. Now we are done with it. Now I'm going to close all the layers. I'm simply going to, okay, simply going here. Now you can see all these buildings, all the road, all these common intersected portions like here you are seeing here. Now what you can do here is, this is the intersected region, this one, and this is the outside region. You are able to see here. Another thing here is simply let's check its attribute table. Now you can see here how many features are here in this OSM ID means this is the building, and its corresponding road, respective road you are seeing here. So you can see here the total features are 1008 buildings, but actually this much buildings are not here. Let's say it's attributable, and you can see here 993. 993 were the total buildings, but you are seeing there 1008 buildings. From where those 14 buildings, like something like that, numbers you saw their extra numbers. That is the intersected portion, that this one, like this intersected portion, there are, I think probably there are 14 kind of that intersected regions that has also been added in this union table, in this feature. Now what you can do is you can simply press Ctrl Shift I, and now you can check it here. Click here. This is the road portion, and you can say is you can see OSM ID is null. It means there is no, this is for building, this is has contain no building. So road is named to Omwa. Okay, that's fine. Now click here. Now you can see here, this is OSM ID, this is the building region. Okay, and it falls in this road to Omwa. And other thing you can see here, simply and remember this OSM ID 96. Okay, first is 96, last is 59. Let's see here. Now click this region. Okay, 9659. You can see this non-overlapping portion as well. So this is what union simply does. Union simply merges all that overlapping, non-overlapping, all the portions that you give input, and this is what overlapping it. If you want to know more, I'll provide all those references link in the description. So now the last remaining geoprocessing tool is buffer, and buffer is also quite similar to this kind of things. It simply increases the area, and if you want to know more about it, I have prepared a separate kind of blog, and I'll provide its link in the description as well. So these were all the main geoprocessing tools that we commonly use in GIS. So thank you viewers for watching this video. We'll meet soon in upcoming videos. Thank you.